Hi, welcome to Learn Easy. Without wasting any time, let's jump into the topic. If you have noticed before, when you're going to purchase an item, you specifically look for weight if it's a food item. So in that details, what you find is a number, say 50 kilograms for example. So weight is a thing which we need to measure or which we need to know about. Okay, so this weight is known as physical quantity. Physical quantity is a quantity which you need to measure, okay, along a specific international reference standard. And the value or the number which is written there, those are called numerical values or a number. And the final thing which we get besides the number is called a unit, and it is represented by a symbol called kg, or if it's a gram, it is represented by a small g. So this whole term is known as unit. This is what we'll be looking into our chapter from now on. Units can be divided into two types. One is called the fundamental unit and another is called a derived unit. Anything which is being derived using the fundamental units, that are called derived units. Okay, as the name suggests, these units are derived using the fundamental units. Fundamental units has a specific set of units. Most of them are weight, okay, then you have length, time, temperature, luminous intensity, quantity of matter, etc. And you have the derived units which are used or derived from these fundamental units. For example, force, you have work and energy, then you have power, etc. In due time, we'll see how this derived units is obtained from a fundamental unit. And now both the units, fundamental and derived units, combined together, it is called system of units. Okay, fundamental units and whatever units which has been derived from fundamental units, which is called the derived units, combining both of them, which is called a system of units. In earlier times, three system of units has been followed. One is called the Cgs system of units, which is a short representation of centimeter, grams, second. Another system of units which was called MKS system, which is meter, kilogram, second. And the third type, which is called the FES system, also known as by another name called British system of units, which is represented as foot, pounds and second. Okay, so in later stages they need a common ground to address a system of units. So they have developed a unit to combine all these three different types into one single entity, which can be followed commonly all over the countries. Okay, so they have employed what is called SI units, okay, which is a representation it's a French name called Système International. System International. Okay, it is an international system which is now later called the International System of Units, and it is represented as SI unit, and which it is from the French origin, which is called System International. These units, the International System of Units or the SI unit, has been developed by a company called International Bureau of Weights and Measurements. So these are some of the questions which might be asked in the examination. So whatever we have discussed so far in our theory, that is all the units, different types of units, these can be asked in these type of questions, which can be asked in the examination, and it ranges from 1 to 3 marks. Okay, so and these type of solving problems which we'll be doing in the next immediately after this, that can also carry up to 3 marks. Previously we have seen that the derived unit is obtained from the fundamental units. Okay, let's take an example and show how the derived units is obtained from the fundamental units. One of the examples for derived units is a work. Work is a derived unit, and it is the unit of work is called joules, which is represented by as J. Okay, so how this derived units is obtained from the fundamental units? And we know that fundamental units consist of basic units or basic physical quantities such as weight, length, time, temperature, etc. Okay, so we're going to use those to derive the derived units. Okay, so work is represented as, okay, work equals to force into distance. This is a simple formula to calculate a work done or energy. Okay, so force is again expanded into force is equal to mass into acceleration. Okay, into the distance what we have. Okay, again mass is kept as mass and acceleration can be further divided. Acceleration is equal to rate of change of momentum, or it is the distance divided by time square. Okay, distance divided by time square gives you acceleration into the distance which is available. Now we know that mass is represented as kg, distance is meter, time is in seconds, so this is second square into meter equals to kg into meter square divided by second square. Okay, so kg into meter square into seconds can be written as s power minus 2. S is nothing but the second. Okay, so final equation is going to be kg meter square per second square, which is called joules. Okay, so joules is a unit of physical quantity called work, and this is how you can see the fundamental quantities such as mass, distance, time, etc. is being used to derive a derived quantity called work. So this is one of the examples to show you how it is derived.
Thank you for watching. Support us by subscribing to our channel and do hit the like and share buttons. Use the comment section to rate our video.